Welcome back to Virtual Learning, Part 1, Increasing and Decreasing Functions and the First Derivative
Test.
Swab at. Determine intervals on which a function is increasing or decreasing. Apply the first derivative test to find the relative extrema of a function.
Excellent. So, what we're going to do today is we're going to break this into about 4 or 5 parts. Should take about a little bit less than about a week to maybe do, maybe a little bit more. Today we're going to go over increasing, decreasing functions. Later on, next week, we'll go over the first derivative test. So, first thing, quick little do now. This is very similar to what you did on your test, and believe it or not, we will be using this again. So why don't you try this really quickly, see if you did well. And as far as the test went, I graded the test, and everyone seemed to have done very well on it. A lot of your grades did go up just because the way it was set up, you either decided to go to different decimal places, decided to go and change. And there was a lot of A pluses in that test. I was very proud of a lot of my students. All right? Now, first thing you should have done, you should have been doing this and finished as I did. Find the X-Intercepts. The way you should have found the X-Intercepts was you set the equation equal to 0. Then you pull out the greatest common factor, which is a 4x. You set both those equal to 0. 4x equals 0. 0 divided by 4 is 0. And you get x squared minus 2 equals 0. You add the 2 and you take the square root. So it's a plus and a minus negative 1.41 or negative positive square root 2. Find the critical points. What you do is derive the equation and set that equal to 0. Add the 8 to both sides. After you add the 8, divide by 12. You get 2/3. Square root of 2/3 is a plus or minus 0.82. Now, once you find the x values, which is your critical number, take these two numbers and plug them into the original equation. Perfect. And you get negative 0.82, 4 35/100ths, and positive and a negative. Points of tangency. This is what you had to do in problems 7 and 8 on the test. Now, what you have to do first is take your A, which is your left endpoint, your B, which is your right endpoint. Plug them into the equation. F of negative 2 equals negative 16. F of B, F of 4 equals 224. Find the numerical value of the derivative. F of B minus F of A over B minus A is 240 divided by 6, or 40. Take this and equate it to the actual derivative of the function. So 40 equals 12x squared minus 8. Add 8 to both sides, divide by 12, and squared is a plus or minus 2. Now, a lot of people messed up and had this equaling 0. That's how you find critical numbers, not points of tangency. Take this, negative 2, 16. If I plug negative 2 into this equation, I get 16. If you plug in positive 2, you get a positive 16 as well. All right? And that you do now, just to make sure you guys are still on point and you did well on the test. Ready? Actual lesson, new lesson. Definitions of increasing and decreasing functions. Now, first thing is to do is something increasing. When something increases, it goes. Yell at the answer when I point to you. It goes up for any two numbers, x1 and x2 in the interval. x1 and x2 are just two numbers on the x-axis. All right, if x1 is less than x2, all right, if it's increasing, if the graph is going up, it implies that f of x1, how is it related to f of x2? Those are the y values. It has to be, what do you think? This number is what to this number? What do you think? What do you think? What do you think? It is? It is less than, okay? Because this is going up, it means this y value of your first function is lower than the y value of the second function. All right? Now, if any two numbers on x1 and x2 in the interval, and x1 is x and less 2, it comes first, it implies that what is going on here now? This number is not less than this number, but it is higher than or greater to the number. Notice this graph travels up, positive slope. This graph travels down, a negative slope. And that is the main way to do this. So in order to test for increasing, decreasing functions, step 1, if f is increasing, if this graph goes up, since we said slope is going to be positive, this means this number has to be, what? What do you think? What do you think? Greater than 0 for all a and b. So that means that it's always going to be higher than 0. If it's negative, if it's decreasing, the slope's going down. So it's not greater than 0, but it is less than 0 for all x and a, b. And this is just an open interval. Finally, if it is constant, meaning it's flat, f of x is not less than or greater than 0, but equal to 0 for all x and a, b. So look at this graph right here. I want you to label the increasing part, the decreasing part, and the constant part.
I'll be right back.
Go. Good. This part is less than 0. The graph is going down, so your slope is less than 0. Right here, your slope is equal to 0, constant, and this graph is increasing, so f prime x is greater than 0. Got it? Good. All right, so what I want you guys to do is we're going to do problems 1, 2, 3, 4. You're going to try it on your own as I explained it to you. And then let's see how this works. So estimate the interval in the graph is increasing or decreasing. So first thing, number 1, we'll do this together. So first off, there is always a point where the graph goes from increasing to decreasing. Can you point it on the graph? Where does it go from going down to going up? Right there. All right? That point right there, that's the point where the slope is 0. And you can see right here, it is going which way? Down. So it decreases, and then it increases. So the increasing part is the second half of the graph, the blue part. So this number right here is not 1, 2, but 3. So it's increasing from 3 to infinity because it increases forever. Now it's decreasing on the first half. So from here to here, even though that arrow points up to infinity, the graph is actually going down. It's decreasing right there. All right? Now, it's decreasing from the biggest number to the left, the lowest number ever is, negative infinity, and it ends at 3. The reason you have parentheses here is at 3, the actual slope is 0, so it's neither increasing nor decreasing. It's a little switch over. So do problems 2, 3, 4, and then I will explain them to you as soon as you unpause. Good, I'm glad you unpaused. Think they unpaused? I hope they unpaused. All right, so first thing here. There's actually 2 points here where the graph goes from increasing to decreasing. Right here and right here. And these points are otherwise known as the extrema. These are the points we found all last lessons. All right? So, first one, it's increasing from here to here, from negative infinity to negative 2. From here to here, it decreases. That's from negative 2 to, still doing increasing. From 2 to infinity, it also increases. And from here, it's decreasing. And that's from negative 2. All right? Problem number 3.
Is it 1 o'clock?
It is... I don't know. I don't gotta watch. Yeah. Yes. So you can go do your other math work. All right. So you have 3 points right here. All right. So it's increasing from negative 1 to 0. It's also increasing from 1 to infinity. It's decreasing from negative infinity to negative 1, and it's also decreasing from 0 to 1. All right. All right. Finally, problem number 4. This little light blue guy is an asymptote, so that's the same as an extrema, but that's when your bottom is set equal to 0. So we also have extremas here at 0 and 1. So you're increasing here from negative infinity to 0. You're also increasing from 1 to infinity. You're decreasing right here and right here. It's not a total decrease because there is no value at 1/2. So it's 0 to 1/2 and 1/2 to 0. 1/2 to 1. All right, we all good? Great. Let's move on. Now, today's lesson is more of a lesson where it explains everything, and then tomorrow's lesson will go explain it, and you guys will try some more problems. The guidelines for finding intervals on which the function is increasing or decreasing. So, number 1, let f be on a continuous interval, AB. To find the open intervals on which f is increasing or decreasing, you're going to follow the following 3 steps. Step 1, locate the critical numbers, all right, in A and B, and use these numbers to determine the test intervals. So in order to find these critical numbers, what do? We set f prime x equal to, that's right, we set it equal to 0, and then we also set it equal to undefined, just like we found our extrema. and then you solve for x. Got it? So that gives you your critical number. Now, next thing you're going to do is you're going to determine the sign at which f prime x, the derivative, is at, and test the value in each interval. So this becomes a little tricky. So you're going to create intervals between the two, what do you think? Yes, critical numbers you just found. You're going to choose a blank from the number between the two blanks. You're going to choose a test value from the number between the two. Match the colors. Blue, blue, critical numbers. All right? Plug in your test value into f prime x and determine if the answer is on the, if it is blank or blank. It could be two things. It can't be 0, but it can be positive or negative. All right? So now we got our critical numbers. We got them set up. We know if everything in between is positive or negative. And the last step is use increasing or decreasing function theorem to determine if the actual value of the graph is increasing or decreasing on each interval. If the value is positive, the function is, as we said before, increasing. If it's negative, the function is decreasing. And that's it. All the rules you guys are going to need to know. So now we can do an example. See, and I can't go too fast because you can just hit the pause button. So find the open intervals on which this function right here is increasing or decreasing. What you're going to do is you're going to set f prime x equal to 0 and find the critical numbers. All right? So, first thing you have here is you're going to derive this equation. So when you derive this equation, f prime x equals 3x squared minus 3x equals 0. All right? Solve for x, as we did before. You pull out a 3x, set both of them equal to 0. 3x equals 0. X minus 1 equals 0. So, x equals 0. And add 1 to both sides, x equals 1. These are my two critical numbers. Now, you didn't find the critical point yet. You just found out what the x values are. So, at 0 and at 1, as you can see here, the graph goes from increasing to decreasing. So, the next step here, that is the two numbers that go on this line. So, from negative infinity to 0, and from 0 to 1, and from 1 to infinity, we have different up and down. So 1 is going to be increasing or decreasing, increasing, decreasing, increasing, decreasing. So we can take those numbers and we plug them into our graph. So this interval is from negative infinity to 0. And eventually we're going to get rid of these boxes and just do the intervals. This interval is from 0 to 1. And then our last interval is from 1 to infinity. So you have 3 intervals here. 1 interval, 2 intervals, 3 intervals. Alright? Now, step 2. Pick a number, any number between negative infinity and 0. What number did you pick? My guess is you picked negative 1. And that's what I picked. So I pick a number between these two, negative 1, and I plug it into the derivative. So I plug it into this equation, not the original equation, the derivative. So this is going to be 3 times negative 1 squared, 3 times 1 minus 3 times negative 1. So it becomes 3 plus 3. And that answer right there is 6. Now here's the tough part. Is 6 negative or positive? It's not tough. It's positive. So since it is a positive number, based on our theory, positive numbers are increasing. And as you can see right here, our graph is increasing. Now typically you're not going to have a graph. I'm just showing the graph to show the relationship between actually doing this and the graph itself. We're going to be creating these graphs from scratch. Now, 0 to 1. What number? I go with a half. You can go to the 4th, an 8th, 7/8, anything. But 0.5 is easy. Type it in your calculator. 3 times 0.5 squared minus 3 times 0.5. It gives you a number of negative 3/4 or negative 0.75. The number itself doesn't matter. What matters is the negative sign. Negative signs are not increasing but decreasing answers. Alright? Last one. 1 and infinity. You could pick whatever you want. You could pick 1,000,000,000 if you want. You'll get the answer. I tell you to pick numbers that are small, so closest to this one is 2. 3 times 2 squared, 3 times 4 minus 3 times 2 is 6. You get 6 again. That's a positive number and it's increasing. Say I pick 10. 300 minus 30 is 270. It's positive. The number itself doesn't matter. All that matters is the sign. And then, if you look right here, we found the critical points by taking this number now and plugging it into the original equation. 0 cubed minus 0 is 0, 0. Plug the 1 into the original equation. You get negative 1/2. Notice it matches up with our graph perfectly. This should be an increase. Then you get a decrease. And then you get an increase. Alright, so then it shows you how our graph actually matches up with our work. So hopefully you're able to do that. I think we have one more problem we'll do today. And we'll see how it goes. So what I want you guys to do is try problems 6 and 7. I want you to find the open interval on which these functions are increasing, decreasing. Alright, hopefully you did it. First thing, step 1, derive set equal to 0. Solve for x. 2x equals 2 and x equals 1. Now we're not actually finding the critical points because we just care about the intervals. Set up your intervals. So since you only have one critical number, it's going to be negative infinity, infinity. Only one critical number means only one number goes on here. We only have 2 intervals, from negative infinity to 1, and from 1 to infinity. And that's it. Last part, pick a number on this side of the graph and this side. So I'm going to pick 0, because that's less than 1, and I'm going to pick 2. You can pick any numbers, though, that fits this criteria. Take my 0. Plug it into the derivative. So 2 times 0 minus 2 is negative 2. Negative numbers mean what? Decreasing. Alright, so it's decreasing on the left side. Type in 2. 4 minus 2 is 2. Positive numbers, so on this side it is increasing. So from negative infinity to 1, it's decreasing, and from 1 to infinity, it's increasing. And this is a parabola, so it makes sense. Try problem 7. Alright, 27 minus 3x squared equals 0. Subtract 27 or add 3x squared to both sides. Divide by 3 and you get x equals plus minus 3. You have to remember when you do a square root, it's going to be plus or minus that answer. Alright, how many critical numbers? 2. Here's your graph. You got a negative 3 and you have a positive 3. So since there's 2 critical numbers, how many intervals are there? 1, 2, 3. Negative infinity to negative 3, negative infinity to 3, 3 to 3, and 3 to infinity. Pick some numbers. Number less than negative 3 is not 0, that's greater than 3. Negative 3. It's a negative and a bigger number. I'm going to pick negative 4. Between these two, let's pick 0 and bigger than 3. Let's pick 4. Plug them all into the derivative. Alright? H prime. 27 minus
Yeah, I think Brittany is doing a morning video.
3, negative 4 is a negative. Decreasing. H prime 0. 27 minus 0 is 0. I mean it's 27.
Coming from
Positive.
like top up for
That's
like,
increasing.
Like it's not a suggestion for
27 minus 4.
me.
Negative 21 is negative, which is decreasing. Alright? Pretty easy, right? What everyone to start with, do now 4.3b. So, should be done. First thing, what are the critical numbers? Where you found that before was you take the derivative of the equation. 1/4 of 4 is 1. 2/3 times 3 is 6 over 3 or 2. And 2 times 4 is 8. Alright? What can you take out of that? You could take an x out. You could factor that. That becomes factors of 8 that add up to negative 2, negative 8 are negative 4 and 2. So, x times x minus 4 times x plus 2 equals 0. I said all three of them equal to 0. X equals 0. X minus 4 equals 0, so x equals 4. And x plus 2 equals 0, so x equals negative 2. So those are your 3 critical numbers. So you're going to take those numbers and use them to set up your intervals. Now the way you set up your intervals is they go from negative infinity to infinity. Then you put these 3 numbers in between the negative infinity and infinity, in ascending order. So the lowest number here is -2. Next lowest number is 0, and then 4. Okay? They're not spaced evenly. It doesn't matter. Just what matters is their order. So the intervals here are from -∞ to -2, -2 to 0, 0 to 4, and 4 to infinity. 4 intervals. Plug in the test values. You can pick whatever numbers you want between these sets of numbers. I picked -3. I picked -1, 1, and let me guess, 5. So take these these 4 numbers, and you plug them into the derivative equation. Not the original, but the derivative, okay? So, plug them into f prime. If you plug -3 in there, -3 to the third, -2 times -3 squared, -8 times -3 is -21. So, -21 is a negative number. That means it is decreasing. -1. Plug it in. Should have got 5. That's a positive number. Plug in 1. You get -9, which is a negative number. All right? Plug in 5. You get 35, which is indeed a positive number. So what that means is, in this interval right here, negative means it is decreasing. In this interval right here, it's positive, so that means it is increasing. Negative means decreasing from 0 to 4, and from 4 to infinity, it means it's positive, it is increasing. All right? There you go. Any questions? Good. Now I'd like you to try problem number 8. Quick little hint. X times that, you're going to have to use the product rule. And you are going to have to rewrite it before you go. So, they're going to be a little harder today. You should be finished. Let's go through the problem. Product rule is f times g prime plus g times f prime. So, first function is your f, that's your x. All right? Derivative of x is 1. Second function is the square root, or that number to the 1/2. So, in order to find that, we have to use something else. We just can't use the product rule. We also have to use the, you got it, chain rule. So, if you didn't use the chain rule, use it now. Good. 16 minus x squared, u to the 1/2, that's your outside and your inside. -2x, because that's 0. And anything to the 1/2 is always 1/2 u to the 1 minus 1/2 minus 1 is -1/2. Multiply these two guys together. Half of -2 is -1. X, u to the -1/2. Then you just plug your u back in for the u. So it's -x, u to the -1/2. Now, finish up your product rule. X times that plus 1 times that. Only thing to combine here is -x times x is -x squared, and this stays the same. So that right there is my derivative. So, you found the derivative, which you know how to do. Now we have to find the critical number. So we have to set this equal to 0. Now, easiest way to do this is, since this is a -1/2, the 1/2 means it's a radical, the negative means it's in the denominator. So rewrite that. This is a 1/2, so that's just a radical. So now we have to try to solve for x. So this is where all the tricky stuff comes. So very carefully think how you would solve for x. Well, if you thought the right way, you would have multiplied both sides by radical 6 minus x squared to get this out. You don't want radicals in your denominator. So what happens here is this cancels out, okay? And then this also gets distributed to here and becomes 16 minus x squared. Now what happens, this is what makes it neat. 0 times this number is 0, so it stays 0. So now look what happens. -x squared minus x squared is actually -2x squared. Subtract 16 from both sides, divide by -2, square root of 8, which is like a number a little bit less than 3. All right, so see, this looked very difficult to do, but you just had to multiply by one thing. Everything became easy. So, let's see. Our intervals, we also have to set equal to undefined though. So when is this undefined? When the denominator equals 0. All right, so we set the bottom equal to 0 when it's less than or equal to 0 actually, because it is a radical. Subtract 16. Or add x squared, take the square root. So it's when x is less than 4 and when x is greater than -4. Alright? So now we have a bunch of weird intervals. Less than 4 means, so first of all, this one is from -4 to negative radical 8. Pick a number between the two. Negative radical 8 to radical 8, and then radical 8 to 4. Because these are all the numbers less than 4, and it has to be greater than 4, right? What that means is, what? That means it can't be less than -4 and greater than 4. So we don't use the infinity. It's a little more advanced of a problem. Pick your test values. -3 seems like a good one. Type it into either this equation or this equation. You get -0.76, which is negative, so decreasing. 0 is a good one. Type 0 in here. What happens when you type in 0? You get 4. All right? Even though the bottom here is 0, 16 minus 0 is still 16, so you still get an answer there. Positive number, increasing. And then you type in 3, and you get a negative number, which is decreasing. All right? So it is a little tricky, just because of this stuff right here, and the radical on bottom. All right? So that's the most difficult you'll see. Let's try the next problem. This problem right here. Seems simple enough, so why don't you solve this? So you're going to set it equal to 0 after you derive it, find the critical number, find the interval, positive, negative. Should be done. Step 1 is rewrite it. Now it's easier to derive. 1 and 4x to the -2. All right? Set that equal to 0. When you set that equal to 0, rewrite it. It's always the easiest way to do this. Subtract 1 from both sides. Multiply both sides by x squared. And then you get x squared equals -4, or x equals the square root of -4. And the square root of a negative is always undefined. So, no critical numbers there. You can set it equal to undefined though. When is 1 plus 4 over x squared equal to undefined? One condition, when the denominator is 0. So when x is 0. Alright? So when x is 0 is undefined, so that is a critical number. Alright? Now, that means we only have 2 intervals, from -infinity to 0, and from 0 to infinity. Nice and easy. Take numbers, say -1. Type in -1. -1 minus 4 over -1. So -1 plus 4 is 5. Or sorry, positive 1 plus 4 is 5. -1 plus 4 is 3. That should say 3. All right. Anyway, it's still positive, which is increasing. All right. Take 1. You got 1 plus 4 is 5. Also positive. It's also increasing. That's weird. Is that possible? Well, if you actually looked at this graph, the 0 right here would be your asymptote, right? And what happens with this graph is it increases here, and it also increases there. So you can have an increasing on opposite sides of the critical number. It is possible, a little rare, but possible. All right? 10 and 11 are trig problems. You could attempt these real quick if you'd like. We're not really going to get into them too much. I just wanted to show you what they're like. So, let's look. Derivative of this is cosine x equals 0. So because this is between 0 and -2, anytime cosine x hits 0 between these 2 points, 1/2 x and 3/2 x. So your interval is going to be from 0 to 1/2 pi, from 1/2 pi to 3/2 pi, and from 3/2 pi to 2/2 pi. All right, and that's just because this was our restraints. Pick numbers between these. I just picked like regular numbers. All right, 1/2 of pi is like 1.7, so between 0 and 1.7 is 1. Plug it into the equation. Make sure your calculator is in degrees. 0.54, positive, increasing. Pi, you get -1, negative, decreasing. 5, doesn't matter what you really pick. You can pick 7/4 pi if you want to. 0.28, positive, increasing. Once again, these numbers don't matter, just their signs matter. All right, so try this one right here. Good. The derivative of pi x over 2 is 1/2. Derivative of cosine is negative sign, so it's -1/2 sine to the x over 2. So, in order to solve this for 0, very simple. When does sine x over 2 equal 0? Because you can multiply both sides by -2. This goes away. 0 stays the same. So let's see, sine x over 2 equals 0 when? All right, so obviously it's 0, because sine is 0, right? Also, because x over 2 equals 0 at 0, right? When is sine 0 equals 0? 0, and you got pi over 2. All right, so what you really want to know is when is sine equal to 0? Well, sine equals 0 at 0, at pi, and at 2 pi, right? So, in order to turn this into a pi, x is 2 pi. In order to turn this into a pi, x is 4 pi. So there's your 2 pi, right? And 4 pi is way out of there. So it's just 0 to 2 pi. It's pretty much the whole entire interval. X equals pi. Pick a number. Negative. So the whole graph would be decreasing for this. And if you want to check all your answers, you can always check Desmos as well. All right? All right. So let's finish up. This says another do now. You could plug it in as a do now, but I just want you guys to try this problem as well. We're going to finish up with this one. We good? All right. So f prime x equals x squared minus 4x equals 0. All right. Take out an x. Perfect square. Plus 2 minus 2. All right. So x equals 0. And this one right here, x squared minus 4 equals 0. So x squared equals 4. X equals 2. X equals negative 2. All right. What are the intervals? Well, you got your big long number line. Negative infinity 2, smallest number is negative 2. Then 0, then 2. So first one right here, negative infinity to negative 2. Negative 2 to 0. 0 to 2, and 2 to infinity. Pick numbers between them. Negative 3, negative 1, 1, and 3. There we go. All right, so to find out if they're increasing or decreasing, take this, plug it in here. All right, negative 3 to the third power minus 4 times negative 3 is negative 15, which is a negative number. Negative 1, plug in there. Guess what? You get positive 3, which is positive. When you plug 1 in there, you get negative 3, which is negative. And when you plug 3 in there, you get 15, which is positive. So, right here, negative means decreasing, sorry. Right here, positive means increasing. Negative means decreasing. And positive means increasing. And that's what you should have got. Hopefully you're doing very well at this, and it isn't that difficult. So let's look at this, theorem 4.6, the first derivative test. Let C be a critical number of a function that is continuous on an open interval I containing C. If f is differentiable on that interval except possibly at C, then f of C can be classified as the following. 3 things. First derivative test tells you 3 things. Number 1, is it a relative minimum? So that's if f of x, right here, it changes from negative to positive. All right, negative slopes go down, positive slopes go up. Oh, jumped the gun on the positive, okay? So if you go from a negative slope to a positive slope, you have a minimum. Pretty obvious. So you have a maximum when you, yell it out. You go from a, where we at? Oh, this is like a valley. Sorry, like if you're in the mountains, the valley you're in, fill up with water if you pour a glass into it. All right, so this one goes from a positive to a negative. All right, f of x is greater than 0 is obviously positive, less than 0, negative. Didn't think you need to know that, but if you want to, you can. So this isn't like a valley, this is the opposite of valley, which is a, where was the P? E, A, peak. Now you have the third choice. It's neither relative minimum or a relative maximum. Now, if f prime x is doing, what is it doing here on both sides? Positive on both sides because you got 2 positives, increasing, they're both greater than 0. Or it's not a maximum and if it is, opposite of positive, negative on both sides. So that is a negative and a negative. It is less than 0. So if it decreases, levels off and decreases again. So you can have situations where it's neither positive nor negative. Got it? Now, let's apply it with problem number 12. Now, f of x equals 1/2 x minus sine x on the interval from 0 to 2 pi. So we're going to find the relative extrema of the function. So first thing I want you guys to do is derive this equation right here. Yes, can I help you? You can help if you like. Derivative of 1/2 x is 1/2. Derivative of negative sign is minus cosine x. Or to solve for xu, add cosine to both sides. You get cosine x equals 1/2. So when does cosine x equals 1/2? This is the cosine curve. So it equals 1/2 here and here. All right? That's at pi over 3, and that's at 5 pi over 3. Now, not everyone could do this in their head. You can use the unit circle 1, or you can also use, in the back of your books, there's a page that actually tells you all the different things cosine x equals. It says all the things they equal, and then it tells you what x would be. All right? Anyway, these are my two critical numbers, so they go in my two boxes. Why did I put these numbers like this? Well, this is what 2 pi is as a decimal. This is what this is as a decimal, and this is what this is as a decimal. All right, now the decimals are a little bit better because what they do is they help you just find the intervals better. Anyway, if I plug in a 1 into here, I get negative 0.4. If I plug a 2, which is between these two, in between the two, you get 0.92. And between these two, I guess you could have like a 5.5, a 6. All right, you get negative 0.46. So, if you look at your graph right here, you can see it goes down, goes up, and then it goes back down. Now, the way you should have filled out your chart, if you did that, pi over 3. This is my 5 pi over 3. 0 to pi over 3, pi over 3 to 5 pi over 3. Same, you could use numbers too. All right, we said this one, our test value was 1, right? And we got negative 0.04. This test value is 2, which is a negative, which is decreasing. This one right here, we used our test value between these two is 2. We found our answer to be 0.92. Positive number increasing. And then here, we use 6, plugged it in, all into the derivative. Negative number, which is decreasing. All right, all nice and easy. Got it? Awesome. Now, here's the table I was talking about before. So if you look right here, 1/2. So you look at the table, and you go, okay, cosine is 1/2, so I go for about 0.5. 0.5. That's 60 degrees. All right? 60 degrees, you would then go to your unit circle and say, where is 60 degrees at? 60 degrees happens to be both of them. All right? There it is right there. Got it? So this is a table you would use, then you convert the angles to the other stuff. We don't really have to worry about that in here, but it's something you'll see in college. I would like you guys to try problem 13. All right, you should be done. You have to use the chain rule to derive this. U, F of U. X squared minus 4 and U to the 2/3. 2x minus 0. 2/3 U to the 2/3 minus 1 is a negative 1/3. All right, multiply these two together. 2x times 2/3 is 4x over 3. All right, and then you plug your U back in for U. Now, this is raised to a power, just so you know. Now, what you want to do is you're going to set this equal to 0. But before you do that, you want to rewrite it. Negative 1/3 means this goes on the bottom, and it is a cubed root. That's why I made it green. All right? We got to set it equal to 0, set it equal to undefined. So, first off, when it's 0, the numerator equals 0. So when does 4x equal 0 when x is 0? Now, when you make this undefined, you set the denominator equal to 0. 3 times cubed root of x squared minus 4. Divide both sides by 3. Cube both sides. 0 stays the same and all this. Now add 4. And the square root of 4 is a plus or minus 2. So you have 1, 2, 3 critical numbers, and that's where they go. Negative 2 is the smallest. 0 is the middle. And then 2 is here. Now what you're going to do is you're going to create your intervals. Between these two is negative infinity to negative 2. I just used the one we used to use with domain and range because that's a little nicer than putting the x greater than less than, I think. Negative 2 to 0, 0 to 2, 0 to 2, and 2 to infinity. All right, once you got these set up, test value number between those two, negative 3. Now, I don't even care what the actual answer is. When I type negative 3 in here, I get negative 12 over 9 minus 4 is 5. So 3 times the cubed root of 5 is some positive number. The key here is a negative over a positive is a negative. Negative numbers are decreasing. Once again, number doesn't matter. All that matters is the sign. Type in -1. -4 over another negative. All right, because this becomes a negative number right here. Negative over negative is indeed positive. Increasing. All right. 1. 1 over some type of negative number. Positive over negative is a negative. It is decreasing. And then finally right here you got 3. Positive over positive is a positive number, which means your graph is increasing. All right. All good? Awesome. Number 14. Find the relative extrema of x to the 4th plus 1 over x squared. So what you guys should have been doing here was you should have used your quotient rule. So I'll give you a little time to do that if you haven't done it yet. Once again, you hit the pause button to slow me down. F is your numerator, x to the 4th plus 1. G is your denominator, x squared. All right, so derivative of this is 4x to the 3rd. All right, derivative of x squared is 2x. F prime times g, g prime times f. 4x cubed times x squared is actually 4x to the 5th. Negative 2x squared times x to the 4th is negative 2x to the 5th. Negative 2x times 1 is negative 2x. All right? Subtract these two numbers, combine like terms, you get 2x to the 5th minus 2x over x to the 4th. All right? Not too bad yet. So what you're going to do is you're going to take the numerator, set that equal to 0. That's when your whole example is 0, your numerator is 0. You are going to take a 2x out, set the first piece equal to 0, set the second piece equal to 0. So divide both sides by 2, x is 0. X to the 4th minus 1 equals 0. Add 1 to both sides. What to the 4th power equals 1, but a positive and a negative 1. So you have 1, 2, 3 critical points. All right, now you also set the denominator equal to 0. All right, when you set that equals 0, x to the 4th is 0, x is 0. Notice, same number, so same critical point, so you still only have 1, 2, 3 critical points. Let's go in order. Smallest number of all these is a -1. Then you have 0, and then you have +1. Negative infinity to -1 is my first. -1 to 0, and then 0 to 1, and 1 to infinity. Pick your test numbers between each one of these intervals as you did before. -2 is a good one. When you plug it into this equation right here, you get -3.75, which is a negative number, which means your graph is going to be going down. All right, take a number between these two, like 0.5, plug it in here. All right, make sure you type it in your calculator correctly. You get 1, which is a positive number, which is increasing. So you're going to be decreasing and then increasing. Number between these, this was the -0.5, so pick a positive 0.5. Type it in here, you get -1 as an answer, negative number, which means your graph is decreasing. 2, you get 3.75, which is a positive number, which is also increasing. So your graph is going to go down, and up. All right, there's also a asymptote at 0. So at 0, there's actually no extrema. It's just a vertical asymptote. All right, now what I want you guys to do for 15 and 16 is find the example. All right, find the critical number. Also find the critical point. So do that for the first step. Good. So to find the critical number, you derive that. You get 2x minus 4. You add 4 to both sides, divide by 2, and you get x equals 2. Now to find the critical point, you're going to take that 2 and plug it into your original equation, because this is your x value, you need your y value. 2 squared minus 4 times 2, 4 minus 8 is -4. All right? So your actual extrema, your maximum or your minimum point, is 2, -4. Now that we got the actual point, we can find out what it's doing on both sides of this point. So you set up your intervals from -infinity to, your critical number, which is 2, and from 2 to, positive infinity. Pick a test number. Hopefully you picked the number. I picked an easy number like 0. When I plug 0 into my derivative, 0 minus 4 is -4. Negative numbers mean my graph is decreasing. Then you pick a number between here. I picked 3. I don't know what you picked. 2 times 3 minus 4. 6 minus 4 is 2. 2 is a positive number. Positive numbers increase. If I picked a number like 5, 2 times 5 is 10. 10 minus 4 is 6. 6 is still positive. It's still increasing. Any number you pick between these two is going to be positive, making it increase. And this is actually a parabola. It goes down, hits this point, and goes back up. All right, so try problem 16. Same concept that we did here. Good. 2x plus 6 equals 0. Subtract 6 from both sides. 2 is -6. Divide by 2 and x equals -3. All right. Take negative 3, plug it into that equation, you get negative 17. So our extrema, our max midpoint, is negative 3 and negative 17. Also, since this goes from decreasing to increasing, tells us that's a minimum. So, critical numbers, negative infinity 2, negative 3, negative 3, 2, positive infinity. Pick a number between these two. It's not 0, because 0 is actually here. It's like negative 4. Negative 8 plus 6 is negative 2. Negative number, once again, decreasing. Good number here is 0. 0 plus 6 is 6. If you picked 1, 2 plus 6 is 8. If you picked negative 2, negative 4 plus 6 is 2. All cases are positive. It means it's increasing. So you're going to decrease, increasing, meaning this point right here is a minimum. All right? Good. Once you do 17, 18, the same exact way. All right? Let's go over them real quick. Derivative of that, 4x plus 4, add 4 to both sides, or sorry, subtract 4 to both sides, divide both sides by negative 4, x is positive 1. Take the 1, plug it into the equation to get your extrema. You get 5, so your point is 1, 5. Extremas are points, remember. Now you take your critical number, negative infinity to 1, and 1 to infinity. Number between these, good number is 0. 0 plus 4 is 4. Positive number, which is increasing. And let's go 2. Negative 8 plus 4 is negative 4. Negative number decreasing. So this graph actually goes up, and then it goes back down. It goes up to 1, 5, and then it goes back down. All right? Right here. Distribute that negative first. Negative x squared minus 8 minus 12. Now you derive it. Negative 2x minus 8 minus 0 equals 0. Add 8, divide by negative 2. X equals negative 4. Take that negative 4, plug it into either one of these equations. I can plug it in the top one. 16 minus 32 plus 12, a negative answer. So it's a negative negative 4, which is a positive 4. So your extrema point is negative 4, positive 4. All right, one critical number means we go from, once again, correct, negative infinity to 4, negative 4, negative 4 to infinity. Number between these two, negative 5. 10 minus 8 is positive 2. Positive 2 means the graph's going up. Let's go with the 0. 0 is always a good one. Negative 8. Negative number decreases. So the graph goes up, hits the maxima, relative maxima, negative 4, 4, and then it goes back down. Got it? Awesome. All right, let's finish up with 19 and 20. You do not have to find the points. So this one, just find the critical numbers. After you find the critical numbers, find the intervals where they're increasing, decreasing, and then find the, that's it. All right, should be done. Derive. 6x squared plus 6x minus 12 equals 0. Now we can use that rule that we did. No, you don't have to. You can just take a 6 out. If you divide everything by 6, this becomes 1, 1, negative 2. 0 divided by 6 is 0. Now this is easy factoring. X plus 2, x minus 1. Set them both equal to 0. X plus 2 equals 0. X equals negative 2. X minus 1 equals 0. X equals 1. All right? So you got from negative infinity to negative 2, negative 2 to 1, and from 1 to infinity. Number between these two is negative 3. That's okay. Goes 24. 24 is a positive number. Positive numbers increase. Right here, good number 0. Put 0 in there, you get negative 12. Negative 12 is a negative number. They decrease. 2. 24. 24 is a positive number, which means your graph is increasing. All right? So your graph's going to go up, down, and up. And you can plug these in to find the actual points if you want. We just know how to do that already, so it's just overkill at this point. Problem number 20. Derive. 3x squared minus 6 equals 0. Add 6. Divide by 3. X squared equals 2. So take the square root. X equals negative radical 2. And also radical 2, or a plus minus. That's also a plus minus 1.41. Negative infinity to negative radical 2. Negative radical 2 to radical 2. And radical 2 to infinity. If you prefer to use fractions, you may. Negative 2. Plug that into this equation. 3 times 4 minus 6 is 6. 6 is a positive number. Positive number means my graph is increasing. Good number between those two is 0. 0 minus 6 is a negative 6, which is a negative number, which means my graph is decreasing. What do we want to pick here? 2. 2 times 4. 3 times 4 is 12. Minus 6 is 6. Positive number, increasing. So our graph goes up, down, up. All right, let's start with this one. Problems 21 and 22. Why don't you guys attempt to find the answers? We're doing the same thing we did on the last lesson. All right, so the first thing you guys should find is the derivative. Now, the way to find the derivative, you don't really want to use the quotient rule because there's just a coefficient down there. So you divide each one of the numerators by the bottom number, x to the 5th over 5 minus 5x over 5. You reduce 5x over 5 is just x. So you got 1 over 5, x to the 5th minus x. Now, that is not your derivative yet. That's just rewriting the original equation. Now, what you're going to do is you're actually going to derive that. 5 times a 5th, woo, it becomes 1. So you got x to the 4th minus 1 equals 0. Solve for x. Add 1 to both sides. What to the 4th power equals 1, but positive or negative 1. All right? These are both my critical numbers. If I wanted to find the critical points, I would just plug them into that equation. You don't even have to do that for these, though. We're going to use them to find our interval. So as with always, you start at negative infinity, go to the lower number, which is negative 1, negative 1 to the positive 1, and positive 1 to number we always end with, which is infinity, open interval. So pick a test number, negative 2, it's just a little bit less. Type it in here. That should say negative 2 to the 4th power. Minus 1 is 15, because negative 2 to the 4th is 16 minus 1 is 15. Little mistake there. Next one, so that's a positive number, which is increasing. So the graph starts by going up. Between these two numbers, 0 to the 4th, 0 minus 1 is negative 1. That is a negative number, and negative numbers are decreasing. All right, then you got right here, pick a number like 2 to the 4th power. 16 minus 1 is also 15. 15 is a positive number, which is increasing. So your graph goes up, down, and up. All right, 22 should already be done. Derive it. 4x cubed minus 32 equals 0. Add 32 to both sides. Divide by 4. X cubed equals 8. Now, because it's a odd exponent, you're only going to have one answer. What number times itself? 3 times is 8, and that would be 2. All right, so you only have one critical number, from negative infinity to 2, and from 2 to infinity. Let's pick 0. All right, 0, plug it into the derivative, not the original equation. You get negative 32, which is a negative number, which is decreasing. All right, 3, 76, which is a positive number, which is increasing. All right, that's it. All right, let's look at problem number 23. This one's a little more difficult. Notice you get a whole big box to fill this in on. All right, so when you derive this, you get 1/3 x to the negative 2/3. You want to rewrite this because you're going to set it equal to 0 and equal to undefined for your critical number. So first off, when I set it equal to 0, never equals 0 because you can never get the 1 to equal 0. Since the numerator can never equal 0, you never equal 0. So f prime x never equals 0, but it can be undefined. So when it's undefined, you want this equation to be undefined. So when something's undefined, what is equal to 0? But the denominator. So you set the denominator equal to 0, divide 0 by 3, okay? Cube 0, 0 cubed is 0, and take the square root of 0, which is 0. Obviously, you can do that in your head if you want, but your answer is 0. So that is going to be your critical number. Now that means you're going from negative infinity to 0 and from 0 to infinity. Let's pick negative 1. It's between these two, right? Type it into the equation. You can type it into this or into this one. I think this is just easier for me. Negative 1 squared is 1. Cubed root of 1 is 1. Answer is 1/3. 1/3 is a positive number. Positive numbers increase. Pick a number 1 here. 1, 3 times 1, it's also 1/3. 1/3 is also positive, which is increasing. So what happens in this graph pretty much is your graph is going to go up. There's going to be an asymptote here at, no, there's no, it just goes up, and it goes up some more. So this is more like a level off, not a critical number. So you don't always have a critical number. All right, derive it. Go. Derive set equals 0. Now this should be a hint of lots of stuff going on. Problem number 24. What we're going to use here is the chain rule. All right, so the way you use the chain rule, you take the inside there, which is x squared plus 2. Your outside is your raised to the 2/3 power. Derivative of x squared plus 2 is 1 plus 0, which is 1. 2/3, u to the 2/3 minus 1 is a negative 1/3. U prime times f prime u. 1 times anything is itself, and then you plug your u back into the u. So 2/3 x plus 2 to the negative 1/3. Now you're going to set that equal to 0 and also undefined. First thing you want to do is rewrite this. So since this is a negative exponent, it is going in the denominator. Since it's the 1/3 power, it is going to be the cubed root. Okay, if this was the 1/2 power, this would be a square root. If this is the 1/4 power, negative obviously, this would be a 4th root. So in order to set this, you set this equal to 0 first. So you're going to take the denominator, which is 2, all right, and you set that equal to 0, because when I multiply both sides by the denominator, it becomes 0 equals 2, which never happens, and 0 never equals 2. There is no critical number based on the answer being 0, the derivative. So now you're going to set this equal to undefined, and then when you set it up equal to undefined, you get the denominator equaling 0. Divide by 3. Cube both sides, 0 to the 3rd power is 0. And then you subtract 2. So you end up actually getting your critical number to be negative 2. So now when we go do our intervals from, once again, negative infinity to negative 2, and from negative 2 to, you got it, infinity. Pick a number between these two. Something like negative 3 is pretty good. Plug it into this equation to, if I type 10 in there, I get a negative 2/3. Negative 2/3 is obviously a negative number, which means it is decreasing. Put negative. We'll go with negative. All right, this right here, you type in 6, you get a positive 1/3, which is a positive number, and positive numbers right here happen to be increasing. All right, so the graph is going to go down and then back up. All right, feel good? Perfect. Now I want you guys to attempt problem 25. Good. Are you done with 25? Hopefully you are, because you used the quotient rule. Numerator x squared, denominator x squared minus 2. Guess what? Both primes are the same, 2x and 2x. Cross, multiply, or use your equation, f prime g, 2x times x squared minus 9, g prime f, 2x times x squared. Now, over g squared, 2x cubed minus 18x minus 2x cubed. 2x cubed minus 2x cubed is 0. You have a negative 18x over x squared minus 9 quantity squared. Now you're going to have to set this equal to 0 and undefined. So when it's equal to 0, you set the numerator equal to 0. Negative 18x equals 0. Divide by 18 and x equals 0. Set the denominator equal to 0. X squared minus 9 equals 0. Square root of that. Add 9 and square root. And you get a plus or minus 3. 0. Negative 3, positive 3 are your 3 critical numbers. So you go in order. Negative 3, 0, positive 3, negative infinity, negative 3, negative 3 to 0, and 0 to 3, and 3 to infinity. 1, 2, 3, 4. You got 4 intervals here. Find a test value. So first thing we're going to do is negative 4. You plug it into this equation right here. Negative 18 times negative 4 times negative 4 squared minus 9 is a positive 1.5. Positive numbers increase in negative 1. Type it in, blah, blah, blah. Calculation spit out a positive 0.3 as an answer. That's positive, which is also increasing. If you type in a number here like 1, all right, look at negative 18 over positive number, negative. All right, you don't even have to do the math if you don't want, but you can. Negative numbers are decreasing. Type a number such as 4 in here, negative over a positive. Obviously, the answer is negative, which is decreasing. So the reason you're going increasing, increasing, decreasing, decreasing is because at negative 3 and at 3, you have 2 asymptotes, okay? So what happens here is the graph is going up, and then between the 2 graphs, your graph is going to make like an upside down parabola, and then after the graph, your graph is just going to continue to go down. And we're going to get into graphing next time. All right, we all good? Try problem number 26. All right, hopefully you're done. Should divide both of these by x squared, x over x squared, 4 minus x squared. If you want to use the quotient rule again, x minus 1 plus 4 times x minus 2. So derive this, you get negative x, negative 1 minus 1 is negative 2, negative 8, x to negative 3. All right, now rewrite that because you're going to have to set it equal to 0 and undefined. Now, when you set this equal to 0, 1 over x squared minus 8 over x cubed equals 0. So the easiest way to do this is add 8 over x cubed. both sides. Now, multiply both sides by x cubed. All right, and multiply every time by x squared. All we did here is cross multiply. 1 times x cubed times 8. Divide both sides by x squared. You get negative x equals 8 and x equals negative 8. If you want to check your answers, you can plug them in and you'd actually get 0. Now, when are they undefined? When either one of these guys equals 0. So when x equals 0, because they both equal 0. So you have two critical numbers, 0, negative 8, negative infinity to negative 8, 0 to negative 8. Oop, that went backwards. No, sorry, negative 8 to 0, and 0 to negative 8. All right, now picking the negative 4 between these two numbers. All right, negative 9, sorry, how I said negative 4. 0.01, which is negative, which is decreasing. Negative 1 between these two. You get 7, which is a positive number, which is increasing. And then if you pick something like 1 between these two, you get a negative number, which is decreasing. All right, are we good? Awesome. I gotta clean up these slides a little bit. All right, last question. Got it? All right. This one you have to use the quotient rule for. X squared minus 2x plus 1. X plus 1. 2x minus 2. 1. Got it? 2x minus 2 times x squared plus 1 minus 1 times all that. 2x cubed plus 2x minus 2x minus 2 minus x squared plus 2x minus 1. All right, we're going to combine some like terms here. 2x squared is owned by itself. 2x minus 2x is 0 plus 2x is 2x. Negative 2 minus 1 is negative 3. X plus 1 squared stays x plus 1 squared. And that is your derivative. So what we're going to do is we're going to finish this up very simply by setting the numerator and denominator both equal to 0. When this equals 0, the numerator equals 0. Factor that. Factors of 3, negative 3 that add up to 2. 3 minus 1. X plus 3, x minus 1. X plus 3 equals 0. X is negative 3. X minus 1 equals 0 and x is 1. When we set this equal to undefined, when does the denominator equal 0? So when x plus 1 equals 0, subtract 1 from both sides and x equals negative 1. Notice 1, 2, 3 critical numbers. The smallest one is negative 3, negative 1, 1. Negative infinity, negative 3, negative 3, negative 1, negative 1 and 1, and 1 and infinity. Test value, negative 4. Positive, increasing. Test value here, negative 2. Negative and decreasing. Test value here, 0. Negative and decreasing once again. Ooh, interesting. Because you got a negative 3 over 1. All right, 2.6. Positive and increasing. So it goes up and down. All right, negative 1 is actually an asymptote. And then it goes down and up. All right, and that is your graphs. And that's the end of this. And then we'll continue on with increasing functions.